In this video, we present MicroBrowser, a system to facilitate peer learning and knowledge sharing in classroom settings. Students in STEM majors, especially those taking upper-level courses, are expected to acquire not only domain knowledge, but also skills for handling open-ended and even ill-defined problems. Class and capstone projects are intended to address such limitations. However, close and in-depth faculty member involvement is needed to support good learning outcomes, making open-ended project-based learning not scalable. We present MicroBrowser, a pattern-based interactive knowledge visualization and exploration system to facilitate peer learning and knowledge discovery for open-ended PBL learning in STEM education. MicroBrowser converts hundreds of student-generated discussions into a structured knowledge graph-based on topic similarity. MicroBrowser supports streamlined knowledge graph navigation and enables patterns as supernodes in this graph for effective knowledge discovery and peer learning. The integration of design patterns in knowledge generation and discovery is a key innovation in MicroBrowser. The pattern nodes serve as insightful, reusable knowledge nuggets. Pattern nodes can be associated with each other to create a pattern language. The pattern nodes also provide the context and actual example of reusable knowledge by the connection with corresponding discussion nodes in the knowledge graph. MicroBrowser has three main components: the knowledge graph view, the discussion view, and the knowledge timeline. Let us take a look at the application. Upon opening the application, students are presented with an overview of the knowledge page, showing the most recently updated discussion. Color coding represents discussion popularity and connection between design similarities. Searching for discussion using keywords is as simple as entering the keyword. Let us now assume that a student missed class due to illness and would like to figure out what discussion occurred in June 1. Let us now assume that the student was told. Let us now assume that the student missed class due to illness and would like to figure out what discussions occurred since June 1. The student uses the date field to narrow the timeline. Let us now assume the student was told to focus on discussions about performance views. Thus, the student can combine the date filter with the keyboard filter. Now let us assume the instructor gave an assignment to perform a comparison between two products. The instructor suggested referring to the question J unit versus test NG as an example of how to complete the assignment, but recommended you should look at other examples as well. How can you find such examples? We can complete this task by using design patterns. Let us first navigate to discussion J unit versus NG test. Finding more information about the discussion is as simple as double-clicking on it. The discussion details opens up and we can see related discussions, answers, and related patterns for the discussion. The color of the answer nodes help to quickly identify the accepted answer, while the size of the answer nodes represent the number of votes an answer has received. We know that the pattern associated with the discussion is called comparator. Mousing over the pattern node, we know that the description of the pattern can lead us to samples of other discussions performing comparison. Thus, we open up the details of the pattern and now we can find other discussions that perform comparisons. In conclusion, MicroBrowser is a knowledge discovery and creation system for educational settings. Its major contributions include the use of a 2D visualization that uses time information and relationship between discussion threads, and the use of patterns to help students to discover and create knowledge.